In this second video on functions, we're going to practice graphing a function. Before we start, I want to review what a graph looks like. A graph is made up of an x-axis, which is the horizontal line, and a y-axis, which is a vertical line. The x-axis is the independent variable, and the y-axis is dependent, and it depends on what the x is. So when we go to graph our function, we need an ordered pair, and our ordered pair needs to be an x value and a y value. So if you look in our table, I have a column for x's and a column for y's, and then I have a column for the ordered pair x, y. Because x is independent, I'm going to choose my values for x. And the rule that we're going to graph is y is equal to 4x. So wherever I see x, I'm going to replace it with the values I choose for x, and then calculate the value for y using order of operations. So in this example, I'm going to choose the values of x to be -1, 0, 1, and 2. Now I'm going to replace the x value with -1. So I have the expression 4 times -1, and 4 times -1 is -4. So the ordered pair is -1, -4. Next, I'm going to replace the x with 0, and this expression is going to be 4 times 0, and 4 times 0 is 0. So the ordered pair is 0, 0. And next I'm going to replace the x with a 1. So the expression is 4 times 1, and 4 times 1 is 4. The ordered pair then is 1 and 4. And finally, I'm going to replace the x with a 2. So the expression is going to be 4 times 2, and 4 times 2 is 8. So the ordered pair is 2 and 8. Okay, this is our table from the previous slide, and I already went ahead and I graphed the point 0, 0, 1, 4, and 2, 8 on my graph. Here's the point 0, 0, 1, 4, and 2, 8. And I'm just going to quickly insert the last ordered pair which I had, which is a -1, -4, which is about there on my straight line. I drew the straight line after I plotted the points, and if you graph this function correctly, you should end up with a straight line. All right, in our next example, we're going to graph the function y is equal to 3 minus x. The values for x I'm going to choose this time are the same. I'm going to use -1, 0, 1, and 2. And wherever I see the value for x, I'm going to replace it with the values I've chosen. And I'm going to start now with my first one. And I have 3 minus a -1, and 3 minus a -1 is a +4. Think change, change. The ordered pair is a -1, +4. The next one would be 3 minus 0. 0 goes in for x. 3 minus 0 is equal to 3. So the ordered pair is 0, 3. The next value for x will be 1. So I replace x with 1. So I have 3 minus 1, which is 2. And I get the ordered pair 1, 2. And last, I replace x with 2. So I have 3 minus 2, which is equal to 1. So the ordered pair is 2, 1. I move over to my graph, and I graph the first ordered pair, which is a -1, 4, which is about there. The next ordered pair is 0, 3, which is there. And then I graph 1, 2. And then finally I graph 2, 1. And I notice that my dots are all in a straight line, and I'm going to try very hard to draw a straight line through them. And I'm going to add some arrows to symbolize that this is a line and not a line segment. And that is the graph of the function y is equal to 3 minus x. Okay, everything that we have graphed so far is called a linear function. What that means is that we are graphing a function whose graph is a straight line. So this is an example of a linear function, and this is an example of a linear function. And both of the examples we've done so far are straight lines. If you graph and you end up with something that is not a straight line, you have done something wrong and you need to go back and check and see if your math is incorrect, because guaranteed your point belongs on the line. You just added, subtracted, multiplied, or divided incorrectly. So let's review the steps to graphing a function. You need to first make an input-output table with a column for x's, a column for y's, and a column for your ordered pairs. Pick 4 values for x. 4 values is insurance that you're going to hopefully get a straight line out of it. You're going to calculate the values of y for each of the values of x that you pick. And then you're going to plot your ordered pairs on a graph. Okay, let's try graphing another function. In this example, we're going to graph the function y is equal to negative 2x, and I've already chosen my values for x to be negative 1, 0, 1, and 2. And I'm now going to replace x with negative 1, so I have 2 times negative 1, which is negative 2. So my ordered pair is negative 1, negative 2. The next one is 2 times 0 is equal to 0, so my ordered pair is 0, 0. And then I have 2 times 1. 2 times 1 is 2, so the ordered pair is 1, 2. And finally, 2 times 2 is 4, so the ordered pair is 2, 4. I'm going to move this up and now graph those ordered pairs. And I have negative 1, negative 2. And it's not coming out exactly where I want it. The point 0, 0 at the origin, 1, 2, and 2, 4. And notice they form a straight line, so I'm going to try to connect my dots, add some arrows to show that this is a line and not a line segment. Let's try another one. Okay, so for our last function that we were going to graph, we have the function y is equal to negative 4x plus 10, and I've already chosen 0, 1, 2, and 3 to be my values for x. So I'm going to replace the x with 0 first, so my expression is negative 4 times 0 plus 10. Order of operations, do the multiplication first. Negative 4 times 0 is 0, plus 10 is 10. The ordered pair is 0, 10. For the next one, I replace x with a 1, so I have negative 4 times 1 plus 10. Negative 4 times 1 is negative 4. Negative 4 plus 10 is a positive 6. So my ordered pair is a 1 and 6. The next one is negative 4 times 2. Negative 4 times 2 is negative 8. Negative 8 plus 10 is a positive 2, so the ordered pair is 2, 2. And finally, I replace x with a 3, so I have negative 4 times 3. Negative 4 times 3 is a negative 12. Negative 12 plus a positive 10 is a negative 2, so the ordered pair is 3, negative 2. I'm going to slide this up now so that I can graph those 4 ordered pairs. And the first one is 0, 10, which is here. Then I have 1, 6. I have 2, 2, 2. And I have 3, negative 2, which is there. Sort of there, right there. Those 4 ordered pairs line up in a straight line, and I'm going to connect them as best I can. I'm going to put arrows on my line to show that it's a line and not a line segment. And that is the graph of the function y is equal to negative 4x plus 10. That's the end of our examples for graphing functions. The next video will be on proportional relationships and direct variation.